thing you're going to do is you're going to look at the numerical values 6, 48, and 54, and off to the side, you're going to identify the smallest number. In this case, it's 6. Then I'm going to identify all the numbers that divide into 6. 1, 2, 3, and 6. And in doing so, I'm trying to identify, is there any numerical value that I can evenly divide out of each of these? So grab your calculator. And I'm going to always start with the largest. So 6 divided by 6, okay, it works. If I get a decimal, it does not work. 48 divided by 6, I'll move this off to the side. 48 divided by 6, it works. 54 divided by 6, it works. So I found the largest number in this list that divides out of each one of these, and so I put a 6 out front. Now we're going to put a parenthesis, and I'm going to ask myself, what goes inside this parenthesis? And so I go 6 divided by 6 is 1. I bring down x to the 4th. I'm going to carry down the symbols. 48 divided by 6 is 8. Bring down the x squared. 54 divided by 6 is 9. If you didn't know those answers and you were working on your own, you just grab a calculator and divide. 48 divided by 6, 54 divided by 6. Now, please make this squiggly bracket. I'm only going to focus on this portion and draw an arrow from the 6 going straight down to the very bottom. We are not going to worry about 6 to the very end when we put our final answer. What do I do with this portion? Okay, let's make that x. And as a reminder from our last class period, A times C goes up top and B goes on the bottom. So if you did not pay attention or you're forgetting, this is your A, your B, and your C, and we're only looking at the numerical values. 1 times negative 9 is negative 9. Positive 8 is your B. What does this tell us? This tells us that when we multiply these two unknown values, they have to be different signs to get a negative 9. So one is positive and one is negative. In order to achieve the product of two numbers being a negative number, they have to be different signs. Also, when they're different signs, this tells us the larger of the two numbers has to be positive. So I'm just going to put big underneath the positive sign. I know when I find the combination of two numbers that works, the bigger of the two numbers has to be positive. Now, when I demonstrate this, if you can do the mental math in your head, that's amazing. And not everybody can. So I'm going to start with 1 divided by 9, or 9 divided by 1, 9 divided by 1. And I'm going to ask myself, because I was able to achieve a whole number, does 1 and 9 somehow combine to give us an 8? They do. They do if we subtract them, right? So 1 and 9 do give us an 8. In order for this to happen, the larger of the two numbers has to be positive. The smaller of the two numbers has to be negative. So if I multiply these, I get a negative 9, and if I combine them, I get a positive 8. For most students, finding this combination is the hardest part. Remember, we're going to forget about 6 to the very end, and then I'm going to start by doing what we learned yesterday. I write down the 1, x to the 4th, I leave a really large open space, and then I bring down the negative 9. So I'm bringing down A and C, and I'm leaving this space open. Now, if you have out a secondary writing utensil, for some students it helps to show in a different color. So in this space, I'm going to take these two numerical values. I don't care which one goes first. What matters is the positive sign is associated with the 9. The negative sign is associated with the 1. So plus 9 and minus 1. And then please make little underlines underneath the B above. We have to take whatever is the variable on the B and we have to attach it to both of these numbers. Moving forward from this part, there's many steps, but it's all things you've learned. So we're going to underline the first two, and we're going to use the concept of factoring by grouping. So when I think about what can I factor out of a 1 and a 9, I can only factor out a 1. But now I have 4 x's here and 2 here. If you're a visual learner, I'm going to make 4 x's and 2 x's. What's the most x's that I can pull out from both terms? 2 x's. Put a parenthesis in back. 1 times 1 is 1. So 1 times 1 is 1. I need 4 x's. That's 2 more. And oftentimes when I'm tired or I'm moving fast, I make small mistakes. So I'm just going to tack 1 times 1 is 1, and 2 and 2 gives us 4. We're good. 1 times 9 is 9. I need 2 x's and I already have them. I'm checking again. 1 times 9 is 9. I need 2 x's, I have them. Whatever is in parentheses comes in back. And I put a really light question mark in front. Now, not every expression you're going to be given today is factorable. So we always have to check to see, does it work for both? I want to achieve both of these terms. Is there a number I can take times 1x squared and achieve negative 1x squared? There is, negative 1. Negative 1 times 1 is negative 1, and we have 2 x's. That works. Negative 1 times positive 9 is negative 9. That works. Now, I'm going to split this group in half. Whether you think of it as like a midline, a half court, 50-yard line, we're going to split it in half. The front and the back both contain the parenthesis 1x squared plus 9. In front of the first parenthesis is 1x squared. In front of the back parenthesis is negative 1. And here's where we can't forget about the 6 that we originally factored out. Please make sure you have all of these steps down on your paper today. Okay, now before we're done, I want you to, before we are done, look on the sideboard and find where it says perfect squares. If this is factorable, the parenthesis that I am right now circling, if this is factorable, each one of these are perfect squares. Is 1 and 9 a perfect square?
Yeah.
Okay. Also, this has to be divisible by 2. 2 is divisible by 2, but I cannot factor this because it has addition instead of subtraction. So there's nothing I can do with this first parenthesis. Now the second parenthesis breaks into 1 and 1, breaks into 1 and 1. Yes, this is divisible by 2, and I have subtraction. So I'm going to make 2 parentheses underneath the second one. And when I divide by 2, I end up with x and x. So 1's and x's go in front. 1's going back, 1 is positive, 1 is negative. This is factored further. Why can I not factor the first one? Because there's addition. This would be my final factored expression. As a reminder, this is equivalent to the original expression. We just restructured it or rewrote it. So we have 8, 30, and 8. Don't worry about positives or negatives. 8, 30, and 8. The smallest number is 8. What number is nicely divided into 8? 1, 2, 4, and 8. So I'm going to start with 8. I'm grabbing a calculator, and I'm going to divide each one of these terms by 8. So I'm going to go 8 divided by 8. Okay, that works for the first and the third. 30 divided by 8. Oh, it's a decimal. I cross it out. 8 divided by 4. Yep, that works. 30 divided by 4. Nope, it's a decimal. Does not work. I know each of these is divisible by 2 because they're all even. So I'm going to put a 2 out front. I am unable to factor out any x's. 8 divided by 2 is 4, and I bring down x to the 4th. I'm going to bring down the signs that are provided. 30 divided by 2 is 15, bring down the x squared. 8 divided by 2 is 4. And then make this little squiggly or curly bracket. And I'm going to draw an arrow for the 2 to go straight down to the bottom. I'm not going to worry about that 2 that I factored out to the very end. Okay, please make yourself an x off to the side. As a reminder, in this position, I'm taking a times c. 4 times negative 4 is negative 16, and my b value is negative 15. This tells me that the signs have to be different. One's positive and one's negative. This tells me that the larger number is going to be, or the bigger number is going to be negative. So if you're confused, how do we get those? I'm going to start with just worrying about the 16. 16 divided by 1. Can 1 and 16 somehow provide you with a 15? It can. 16 is a larger number. 1 is a smaller number. So yes, they multiply to give you a negative 16, and they combine to give you a negative 15. I'm going to write down what is in parentheses, but I'm not going to put the B part, only the A and the C. And I don't want you to get confused here, so I'm going to put a little circle around it. It does not matter if I write down positive 1 or negative 16 first. It's up to you. So positive 1 and negative 16. Now what does matter is what you attach to each of those numbers. I go back up to the B, and whatever variables with the B, I have to attach on to both of these. You could achieve the same answer if you put a negative 16 first. You absolutely could. Out of these two terms, at most I can factor out a 1, and I can take out 2 x's. 1 times 4 is 4, but I need 2 additional x's. So I want to make sure I did this right. I get 4x to the 4th. 1 times 1 is 1, and I have x squared. Make sure that you check to make sure that when you distribute, you get what's up top. Now I take whatever's in parentheses, I write it in back. I'm going to make a really light question mark because not all of these are going to be factorable. Is there a number you can take times 4 and end up with a negative 16? Negative 4. Let's make sure we can do this. Negative 16, x to the 4, or x to the second. Good. Now distribute negative 4. Okay, it works for both. So I'm going to split this in half. And notice that they both have the quantity 4x squared plus 1. 4x squared plus 1. Okay, got that. In front of the first is 1x squared. In front of the second is minus 4. And don't forget about the 2 that we brought down. This is not wrong, but now we have to ask ourselves, there's 3 criterias when you have binomials if you can factor further. First is, are they perfect squares? So if you're not sure, look on the sideboard to your left. Is 4 and 1 both a perfect square? Is the exponent divisible by 2? Do we have subtraction? Okay, can't do that. So I'm going to bring down 4x squared plus 1. Now here, is 1 and 4 also perfect squares? Yes. Is this divisible by 2? Yes. And do I have subtraction? So what do I do with the second one? I'm going to fill in those blanks. The 1 and the x's go in front. The 2's going back. One of them is positive and one of them is negative. This is a trinomial. So in this expression, we have 3 unique terms. Okay, so I go with the smallest number, which is 4. What number divides into 4? We have 1, 2, and 4. So if you can do mental math, awesome. If not, grab a calculator and we're going to start. 9 divided by the largest number of 4, it gives me a decimal. I cross it out. 9 divided by 2, 9 divided by 2 also gives me a decimal. So I don't need to worry about factoring out a 1. It doesn't help me any. All right, what are we going to do then if we can't factor anything out? Let's make our x. A times c. That means 9 times positive 4 is a positive 36. And my b term is a positive 12. Now, I've seen a lot of simple mistakes here with this. So again, I'm going to go over how can you get that 12 if you're feeling confused. Only worry about this top. So I take it and divide it by 1. Notice that because this is positive, it means they're going to be the same sign. They're either both positive or they're both negative. And you know how you can know that? If the value down here, when you combine them, is positive, that means both of these must also be positive. 1 and 36 does not give you 12. 2 and 18 does not give you 12. 3 and 12 does not give you 12. 4 and 9 is close, but it's 13, not 12. When you get a decimal, we ignore it. And here we go. 6 and 6 is 12. So I write down the A, leave it blank, and write down the C. What goes into the space? I'm going to write down this combination that I came up with, plus 6 and plus 6. Now, here's where a lot of students make mistakes. After they identify those numbers, the order doesn't matter. They forget to look up here. And whatever the B is, in this case it has a variable x, I have to attach to each one of those. Okay, so underline the first 2. I can factor out a 3 because 3 is divisible. 3 divides nicely into 9 and also into 6. I'm also able to take out a maximum of 1x out of the first 2 terms. So in my mind, I say 3 times what is 9? Or maybe you just like to use a calculator. 9 divided by 3 is 3. However your mind works. We need 1 more x to come up with 9x squared. 3 times 2 is 6. We have an x, exactly what I want. Take this, copy and paste it in back. And put a really light question mark here. What times 3x gives us a positive 6x? That would be a positive 2. 3 times 2 is 6 with an x. And 2 times 2 is 4. Split this down the middle. And now they both have the parentheses 3x plus 2. In front of the first is a 3x. In front of the back is a positive 2. If you left it like this, that's completely fine. Completely fine. Or you may recognize they're the exact same quantity, so you're going to write 3x plus 2 quantity squared. Okay, you and your partner are going to race. What if you don't get done in time? Totally fine. What if it's wrong? What if you get it wrong? It's fine. Follow closely to my directions, please. Take your paper. Take your paper. Well, watch, please. This is page 1. I want you to find page 2. It looks like this. Page 2 says assignment. Flip to the back of page 2. And find number 7. The very first thing you should do is recognize the smallest number. What is the smallest number? 5. And the numbers that divide in 5 would be 1 and 5. So the first thing I would do, you can do it mentally, or with the calculator. 6 divided by 5, that doesn't work. Cross it out. And dividing by 1 doesn't do us any good. So I'm going to make my x a times c. Now be careful of the sign. 6 times negative 5 is a negative 30. If you're not confident with your plus and minus, then grab your calculator and take 6 times negative 5 to ensure you put down the right number. Your b is negative 7. So this combination here is, I believe, is the hardest part for a lot of students. And so if you're confused, where do I start? Start with 30. 30 divided by 1. This says they have to be different signs. So one's positive and one's negative. This says the larger number or the big number will be negative. So 1 and 30, they don't give me 7. 30 divided by 2. 2 and 15 does not give me 7. 30 divided by 3. 3 and 10 can give me 7. So which one is negative? The bigger one in this case. So 10 and 3. I'm going to write down the problem. 6x squared, leave a blank, minus 5. In this position, I'm going to put plus 3 and minus 10. This is the second mistake students make. What am I forgetting to do? Put an x down. And then I'm going to get started. Which one you put in front? I could put negative 10 in front. I'll still have the right answer at the end. Okay, so I can factor out a 3 and an x. 3 times 2 is 6, but I need 2 x's, attach one more. 3 times 1 is 3, and I have an x. Whatever's in parentheses, I'm going to put in back. And then I need to achieve these last two terms. Negative 5 times 2x is negative 10x. Negative 5 times 1 is negative 5. Split it in half. They both have 2x plus 1. In front of the first is 3x. In front of the back is a negative 5. Now, what's different about examples 1, 2, and 3 is we only had 3 terms. How many terms do I have now? When you have 4 terms, you're thinking factoring by group where you should be. What is the smallest number I have? 6. 1, 2, 3, and 6. Grab your calculator or do mental math, however you want to do it. I'm taking 27. I'm dividing by the largest number, 6. Because it's a decimal, I cross it out. 27 divided by 3, that works. 6 divided by 3, that works. 12 divided by 3 and 24 divided by 3. They all produce a whole number, which means I can factor out a 3. This first term has 4 x's. The second term has 3 x's. The third has 2 x's, and the final one has 1 x. What is the most x's I can take from all 4 terms? 1 x. So how you achieve what goes inside the parentheses is kind of how your mind works. Some students may say 3 times what equals 27. Others may grab a calculator and go, okay, 27 divided by 3, and then they're going to write down the 9. They need 4 x's, or I need to attach 3 more. Again, they're going to take 6 divided by 3 to get 2. They need 3 x's. They only have 1. They need 2 more. The signs that we see above is exactly what will carry through. So 12 divided by 3 is 4. I need 1 more x. 24 divided by 3 is 8. Draw an arrow going straight down for the 3x. And put your little squiggly here. As a reminder, this is different than 1, 2, and 3 in some ways because we didn't start with a trinomial. So let's underline the first 2. I can't factor out a 9. I can't factor out a 2. The most I could factor out is a 1. That doesn't really help me. But I can take out 2 x's. 9 times 1 is 9. I need 3 x's, so I attach one more. 1 times 2 is 2. I need 2 x's, and I already have them. Whatever is there, I go to the back and write 9x plus 2 and make a really light question mark. What value times 9 gives you negative 4? Okay, 12 times 9 is not negative 4, but it's a good guess. It would be a fraction, but that fraction, when you take it times 9 to get this, is not going to give you the value you need for 2. And we're only going to be working with integers when we're doing this. So we don't know a number we can take times 9 and end up with negative 4. So this number does not exist. What do? We cross this out and only circle this. The only thing we could do is factor out the term 3x. Please flip to the back. So what is the smallest number?
20.
So let's put a 20 off to the side, and I'm going to write down the numbers that divide into 20. Some of you will use mental math, awesome, and if you don't have that ability right now, then you're going to grab a calculator. I do not care about the positives and the negatives when I'm deciding what's the largest number I can factor out. So I'm going to type in 245 and divide it by 20. If I don't get a nice whole number, I cross it out. 245 divided by 10, it doesn't work as well. But 245 divided by 5 works. When it works for 1, then I'm going to check the next. 225 divided by 5, it works. And 20 divided by 5, it works. So I'm able to factor out a 5 from every term. Now here's the deal. Can you please put an arrow above the negative sign? When your leading coefficient is negative, we're going to factor out that negative sign. So let's put a negative 5 out front, please. The first term has 5 x's. The second term has 3 x's, and the final term has 1 x. What is the most that you can take out of all 3 terms? 1 x. Okay, here we go. Again, like in my mind, I don't know real quick what is negative 245 divided by negative 5. So I'm going to grab a calculator and I'm going to type it in. Negative 245 divided by negative 5. And the answer is 49. I need 5 x's and I only have 1. I'm going to attach 4 more. Then I'm going to do the same thing. Negative 225 divided by negative 5. Positive 45. I need 3 x's and I only have 1. I'm going to attach 2 more. I'm going to take positive 20 divided by negative 5 to get a negative 4. I need 1 x and I already have it. Please make the squiggly lines underneath what is in brackets or parentheses, however you wrote it. Okay, draw an arrow going straight down from the negative 5x. Okay, now I wish I would have wrote a little bit smaller. I'm going to come down to the bottom here so I have plenty of room, and I'm going to make my x. I am only focused on what I have as a squiggly bracket. So when I determine the AC, I'm going to grab a calculator and take 49 times negative 4. And I believe 49 times negative 4 is negative 196. Let's check. It is true. Negative 196. I want to make sure I'm right, because if I'm wrong, the entire problem will be wrong. A really common remark that I have from students is like, Miss Bradley, I understand how to get to this, but how the heck do I determine these numbers without just guessing and checking and it taking 5 to 10 minutes? This tells us we're going to have different signs, so please make 1 positive and 1 negative. When they're different signs, this tells us the larger number or the big number will be positive. Now this, I know that the difference of the 2 numbers is 45. So I want to choose 2 numbers that have a distance between them on the number line of 45. So I'm going to start randomly right now with 5. I just am randomly going to choose 5. 5. Now if I add 45, do you guys agree that 50 and 5 are a distance of 45 apart? Do you guess? No? Okay. If you don't know that, just grab a number and add 45. And we can see 50 and 5 are a distance of 45. Okay, so I'm going to take these and multiply these and see if this is the answer. Please don't talk when I'm talking. Please don't talk when I'm talking. 5 times 50 is too large. 5 times 50 is too large. This is too large, so I need to bump it down. So now I'm going to go down to 4. 4 and 49. And you're like, how do I know if that's right? Well, let's watch. If I take 49 and subtract 5, I end up with 44. Oh, sorry. Let's go back here. I need 45. If I go with 4 and I add 45 to it, I end up with 49. So 4 and 49 are a distance of 45. So let's say 4 times 49. This time I got the right answer. So it's just, I start with one arbitrary and I go up or down based on the answer I get when I take the product of them. Now, how do I know if 4 or 49 is positive or negative? The larger one must be positive. So here's 49 and this is 4. Okay, let's write down the A, leave a big space, and the C. Okay, you ready? I'm plugging in a positive 49 and a minus 4. Turn to your partner. If I stop right now, what have I done wrong? I've made a mistake. Turn to your partner, not to me. What have I done wrong? Please make marks underneath the B. This tells us what variable and how many of them I need to attach on to each numerical value. So don't go back to the original, go back to the one right above it. Okay, here we go. Everything else is the same that we've worked through. So underline the first two, please, in the first two. I can factor out a 49, and I can take out an x squared. 49 times 1 is 49. I need 4 x's, so I need to attach 2 more. 49 times 1 is 49. I need 2 x's, and I already have it. Whatever's in parentheses goes in back. And I make a really light question mark right here. Not everything is factorable. What times 1 gives us a negative 4x squared? Negative 4. This gives us negative 4x squared. Good to go. And when I distribute to the back, I get negative 4. Okay, so I've done everything good so far. I have a front part and a back part. They both have the parenthesis 1x squared plus 1. In front of the first half is 49x squared. In front of the back half is a minus 4. And do not forget about the minus 5x. If I circled this and I turned this in on assessment, I will not receive full credit. Turn to your partner. What do I need to do more of? Ready, get set, and go. Okay, so you ready? I put down the minus 5x. The only reason I can't go further with this parenthesis is we don't have subtraction. So I write down 1x squared plus 1. Now here, I can go further. This breaks into 7, 7, 2, 2, divisible by 2, and I have subtraction. I know I don't have a lot of room here. The 7 and the x goes in front. The 2's going back. 1 is positive and 1 is negative. So I know that's hard to see, but this is negative 5x times the quantity 1x squared plus 1 times the quantity 7x plus 2, and finally times the quantity 7x minus 2. We are going to move down to example number 7 next. Example number 7. Turn to your partner. In the first 10 seconds, write nothing on your paper. Your partner is gone. They came into class, and you have to tell them what's the first step. Turn to your partner. What is the very first step they should do? Do not do it on paper. Only verbalize. Go. 10, 9, 8, 7, 6. All right, here we go. So I heard Nick up front say it correctly. He said, find the smallest number. We don't care if it's positive or negative. What is the smallest number? So write down 10. 1, 2, 5, and 10. All right, now grab your calculator, and if you can't do the mental math, use the calculator. 24 divided by 10, nope. 24 divided by 5, well, that doesn't work because they're both decimals. But all of these will be divisible by 2 because they are all even. So please put a 2 out front. Turn to your partner. How many m's can you take out of all 3 terms? You have 5 seconds, go. Tell your partner why the answer is not 1. The last one doesn't have an M. Okay, turn to your partner. How many Q's can you take out of all 3 terms? None. Why? Okay, here we go. 24 divided by 2 is 12. Negative 34 divided by 2 is negative 17. Negative 10 divided by 2 is negative 5. Please put these curly brackets right here. The only thing I want you and your partner to do is this. I want you to determine this number, and the combination. You have 4. So I'm going to work myself through this. This is your A, your B, and your C. A times C is negative 60. And now I'm going to work through this as if you are somebody who's like, okay, I get that, but I get confused how to get these answers. This tells you there will be different signs. And this tells me the larger number will be negative. So one's positive, one's negative, and I know the bigger number is going to be negative. Now I'm going to take a calculator, and I'm going to start with this number up top. I don't care about if it's positive or negative. Divide 60 by 1. If you get a nice whole number, then ask yourself, does 60 and 1 somehow give you a 17? No. Nope. Divide 60 by 2. Can 2 and 30 give you a 17? Divide 60 by 3. Can 3 and 20 somehow give you 17? Yes. Okay, now how do you know which one's positive or negative? The bigger one has to be negative, so 20 and 3. Draw an arrow going straight down for the 2, please. Draw an arrow going straight down for the 2. Give me 1 second. Straight down for the 2. Okay, ready? Here we go. So I have 12m squared, leave a big line, minus 5q squared. It does not matter if you put your positive 3 or your negative 20 first, you'll get the same answer in the end. Okay, again, I think there's going to be a lot of mistakes right now. So turn to your partner. What do I need to put behind the 3 and the negative 20?
And a Q.
How do you know it's an M and a Q? You look straight up above, whatever the B is. All right, here we go. So we can factor out a 3 and an M. I'm left with 4m minus, make sure I don't make a mistake. 4m squared plus 1q. Do you guys agree?
Yeah.
I'm going to copy and paste 4m plus 1q in back, and then I need to achieve these two answers. So what times 4 gives us a negative 20? Negative 5. Now, it's really easy to forget something here. Be very careful. Yes, this is negative 20, but what else do I need up above? A q. So negative 20 qm. And this is negative 5 q squared. Okay, what do they both have in common? 4m plus 1q. In front of the first is 3m. In front of the back is negative 5q. All right, you ready? Kim, this is wrong. Kim, why is this wrong? I didn't do any math wrong, Kim. What am I forgetting, kiddos? The 2. Kids consistently forget that. So I look here and I'm going, what is the largest number that I can find here? It is 12 and the smallest number is 8. Numbers that divide into 8 would be 1, 2, 4, and 8. And I'm able to determine that I can factor out a 4. Also, I'm able to factor out an x squared. So inside parentheses, I go 12 divided by 4 is 3, but I need 3 more x's. 8 divided by 4 is 2, and I need 2 more x's. 12 divided by 3 is 3, and I need 1 more x. And 8 divided by 4 is 2, and I already have both x's. I'm only concerned right now with the inside, and I'm going to use this concept of factoring by grouping. So I underline the first 2. What am I able to factor out of a 3 and a 2? Nothing, only a 1. But I can take out 2 x's. 1 times 3 is 3, and I need 1 more x. 1 times 2 is 2, and I have both x's. Again, when I'm tired, I make small mistakes, so let's check. 3x to the third, 2x squared. Whatever's in parentheses goes in back with a like question mark. we don't even know if this is factorable. We got to keep working to try to achieve these last two terms. Is there a number I can take times 3x and I get negative 3x? So when I distribute, I do achieve negative 3x, and when I distribute, I still achieve negative 2. So I have a front and a back. Now they both contain 3x plus 2. I write it down one time. In front of the first parenthesis, 1x squared, and in front of the back is a negative 1. And don't forget about the 4x squared out front. The very last thing is we have to ask ourselves, can we factor any further? So we don't have a perfect square. I can't go any further with this problem. Here I have a perfect square. I have subtraction, and this is divisible by 2. 1 x's are in the front, 1's in the back, 1 is positive, and 1 is negative. We're going to move on to example number 8 for anybody who is taking notes. If you are not taking notes, you are moving forward right now with the homework. Example number 8. You're going to always put an arrow above the negative leading coefficient. We are going to factor that out. So the smallest number I see is 24. Numbers that go into 24, please be quiet. If you are not taking notes, please be quiet. And I'm going to try all of these to figure out what's the largest one that I can factor out of everything. Please be quiet if you are not taking notes. 24 does not work. 12 does not work. 8 does not work. 6 does not work. 4 does not work. 3 does work. And we can see each one of these, I don't have to worry about the positive or negative, but each one of these is divisible by 3. And I get a whole number for all 3. So I'm not just going to factor out a 3, I'm going to take the negative sign with it, and that is a key. Okay, negative 45 divided by negative 3 is a 15. Bring down the r squared. Negative 42 divided by negative 3 is a positive 14 rs. Positive 24 divided by negative 3 is a negative 8 s squared. And I'm making these curly brackets now. And I'm going to start by making this x. So within this area, I'm going to take 15 times negative 8 on my calculator to get a negative 120. And I need to think of how do I find a combination that multiplies to equal negative 120, combines to give you a positive 14. Different signs, and larger one is positive. Different signs, larger is positive. Okay, so I need to think of numbers that are 14 away from each other. I don't know. So I'm going to do I know 2 and 16, for instance. They're 14 distance away. But notice how it's not large enough. So let's go 3 times 17. Not large enough. Let's go 14 times 18. Again, they're 14 away from each other. Not large enough. 5 times 19. I'm getting close. 6 times 20. It works. So 6 and 20 is my combination. The larger number, 20, has to be positive. In this position, I'm going to bring 3 down to the very end. 15r squared, leaving a blank, minus 8s squared. In this open position, I will put a positive 20 and a negative 6. Don't forget to attach an rs to both. All right, what can I factor out of the first two? A 5 and an r. And then we'll be left with 3r plus 4s. Again, let's make sure I did this right. 15r squared, 20rs. Copy and paste the 3r plus 4s with a like question mark. What times 3 is negative 6? That's a negative 2, but we have to be careful here. Yes, I have the negative 6r, but I also need an s. Negative 6rs and negative 8s squared. Front and back both contains a 3r plus 4s. In front of the front is a 5r, and the back is a minus 2s. And don't forget about the negative 3 that we factored out. Let's look at our final one. Number 9. First thing I'm going to do is I'm going to identify the smallest number, which is 28. And then I'm going to identify what numbers divide into 28 nicely. And if I zoom out here, we can see the numbers. Using my calculator, let's see if we are able to factor out any numerical values. So I know 28 works, right? That's how I chose it. 28, oops, sorry. You can see 28 divided by 28 obviously is going to be 1. 100 divided by 28 provides me with a decimal answer. 100 divided by 14 does not work. 100 divided by 7 does not work. But 100 divided by 4 does work. Let's try 48 divided by 4. It also works. So I'm going to factor out a 4. 4 times 7 is 28. 4 times negative 25 is negative 100. And 4 times 12 is negative 48. I'm only concerned about this. I will bring this down at the very end. Okay, here we go. It's our last one right here. So what are we going to do? I'm going to take 7 times 12. I have no idea what this is. I'm going to use my calculator. 7 times negative 12. So negative 84. And my other value, my B value is negative 25. I have no idea. I know they have to be different signs, and the larger is negative. That's all I know. So numbers that are 25 apart, like I'm just going to randomly choose. If numbers are 25 apart, it could be 5 and 30 because there's a distance of 25 from 5 and 30. But when I multiply, it's too high. This is too high. So I'm going to bump down. Let's try 4 times 29. They're still 25 apart. It's still too high. 3 times 28. Perfect. How do I know whether the 28 or the 3 goes in these spots? The bigger one has to be negative. So 28 and 3. Okay, in this position we have a positive 3 and a negative 28, bringing down the WY. And I underlined the first part. The most I can take out of these is a W. I'd be left with 7W plus 3Y. 7W plus 3Y. What times 7W equals a negative 28WY? That'd be negative 4Y. Let's make sure. Negative 28WY. Good. And negative 12W squared. We are almost done. They both contain a 7W plus 3Y. In front of the first is a W. In front of the back is a 4Y. Don't forget about the 4 out front.